please welcome Kevin McCauley. Thanks, Kevin.
Yeah, thank you, Mark, and good evening, everyone. Thanks for joining us this evening. Hopefully there's something for everyone as we go through. There's a fair bit of information here, but of course, we can follow up any one of the points with you directly or do one-on-one sessions. If any of you have any further areas that you want to dig into, again, a little bit higher level on some things this evening in the interest of time, but we can definitely invest in some more review meetings with you if any other things pique your interest. So thanks, Mark. Yeah, I want to touch on just a couple things before we roll into the slides. Yeah, I've been fortunate enough. I started my career here. Henry Rotsaert had actually approached me about coming to work here many years ago, and had an opportunity to get involved with dental implants in the beginning. And by the beginning, I mean when they were launched as a commercial entity in Canada in the late 80s. And they were doing trainings at George Brown for technicians and the University of Toronto. So even in my recent years, I was fortunate enough to work with George Zarb, who was part of that original Brånemark study, and went on to work with Noble Biocare as a product manager back in '99, and had a nice career there for 21 years in various roles, from marketing to the last one before I left was the digital dentistry product manager for North America for Noble Biocare. And within that, as Mark had mentioned, we had a couple of decades of evolution of digital workflows as well as implant launches, and some good, some bad. There was some teachings. I used to call them learnings, but people taught us what they liked or didn't like, and some things stayed and some things evolved further. But more recently, I had an opportunity to work with a company called Keystone Dental, and within their powerhouse, they had a technology called Nexus iOS, and I'm going to talk about that further into the presentation, and share with you a way of streamlining larger span cases or implant cases and be able to get a more accurate fitting framework technically in fewer appointments and still have really good results for the definitive prosthetics. From a disclosure standpoint, some of the slides are from Osteon Medical, Noble Biocare, depending on images as well, and then certain workflow materials. I'll always encourage all of you to always review and also have your team review the instructions for use for anything you're doing. It goes with intraoral scanners as well, but with those protocols, there's a reason why they're there. And I share that because we often get phone calls here asking for implant specific support where the implant representative is unavailable or a company doesn't have one, like some of the smaller companies. So with that said, there's really good resources. Of course, by most companies, it's a requirement before they get registered. So when you start looking at or have an opportunity where a patient comes in and they have a hopeless dentition, right? They have a situation where they need something more. And by that, I mean, it could be staged. It could be what was termed as all on four, which was really full clearance of an arch or the majority of the arch, implants placed, whether they were done with a surgical guide, right, provided by us, with a full implant plan that we've done ahead of time or done freehand, but then the registration of the position of those implants would be picked up by using a denture to register the position, and that would be, after being trimmed up, that would be the prosthetics that the patient wore home. When we do these types of immediate workflows, we really need to start with what we term as the foundation slides or foundation scans, pardon me, as well as some photographic shots of the patient. And we have a really nice photography guide that Mark's put together with the team here, as well as shade verification materials. And by all means, reach out. We usually have them with us at any of the tabletop conferences, but we have some really good materials to help you help us to streamline and get as close as we can to the real patient in a digital world. So from a pre-op perspective, and this goes for most cases, whatever we receive today, even an intraoral scan that comes in, if we can get photographs additionally, that provide us with a patient having a big smile, also give us a big retracted smile as well. This just helps us layer up the images. So like a passport photo, standing up against a wall, flat surface, please not in the chair. We do see some unusable photographs, I would say fairly often. Try to give us the earlobes being visible if possible, but that allows us to line them up from a plane of occlusion, if you will. It helps us line it up and take some measurements ourselves to be able to tie everything together. But these photographs, you know, if they're usable, great, and they're a great tool for us. If you happen to be digging into facial scanners, we have experience with those as well, although they seem to have calmed down a little bit. There was a lot of excitement about those, but really a really good quality 2D photograph is an excellent starting point. We also require what's called the foundation scan. So with that, just like you're doing with any case you're doing today, we get an upper jaw, lower jaw, and the patient's current bite. Now, regardless of the scanner, and I think, you know, we have some poll questions that will come your way that Jen Riv will be sharing. But with that, depending on the scanner that you have, we receive scans quite often where the patient has been clenching. You know, they're over closed, if you will, or the teeth are compressed slightly when you do the bite scan. And we often see there's an intersection between the upper and lower jaw when we do our virtual import and look at it from a virtual articulation standpoint. So bear that in mind. You know, the patients might clench down when you're doing that bite scan. You know, they need to maintain it, but they don't necessarily need to be clenching. We fortunately work with something called bite finder that will actually recalculate a bite based on wear facets and the noticed or acquired wear facets and wear planes on the patient's current dentition, and it will re-articulate the case if needed. But in most cases, we'll of course work with the scan that's provided. But something to keep in mind if you're having your own challenges with high bites or open bites or contacts as well, we can often get a slight shift in the adjacent teeth. So starting off here, when I was talking just about the immediate options for patients, so again, we're taking a patient from what they currently have as their situation. It could be, partial dentures, some remaining teeth. We're trying to get them into an idealized situation, so it would be a full-arch prosthesis. We can do same day, all on four, which is a denture that is then converted, or we do, and what we're seeing more recently and more commonly is what's called just-in-time delivery. So what does that mean? Immediate loading, if you look at ITI studies, they really talk about doing anything shorter than 8 days. So from the time you place your implants, you don't want to be after 8 days before you put the prosthesis in place, right? Might be a bit shocking for some of you, but you can place a bridge next day instead of putting your office and the patient through a full day of waiting after surgery, lab work being done in your office or ours, and returning a prosthesis by the end of the day. There is a workflow that you can have a provisional denture just for a day, and we can provide you with a milled or printed PMMA or file if you choose to do it in-house. But we can have that provided to you for the next day. So the patient's had a chance for the freezing to wear off a little bit, but you're able to get the bridge in there while the tissue hasn't healed and be able to do some ovate pontic work and other contouring of the soft tissues. From a surgical perspective, there's a series of scans that we receive from your office. There's a workflow for this, so we can share with that as cases come forward and you start looking at doing this more. We can have a one-on-one, or Mark and I can come and visit, and we can talk about the various steps that we need to do with your team so that you're prepared to have the conversations with the patient as well. But there's a series of scans that we receive, and again, then we can turn around that provisional and we can create what's called a scan denture or scan template. And that scan template is really a denture, but think of the intaglio surface or the tissue surface as much like a custom tray, right? Once you've taken out those existing teeth, you have to regain or maintain or at least transfer to us the vertical, right? So this maintains that vertical dimension that the patient had in the beginning. And then you just do a very small or fine wash scan, impression inside of this scan template, seated in the mouth, have the patient close down, and then that allows us to then virtually articulate everything and build the project. From there, we just take the pre-done design, merge it with the implant scans, and go to work creating the bridge work. So again, I just wanted to share with you what can be done with immediate workflows. Again, we do surgical guides every day. Some of them are virtual guides in the sense that they have an access hole, call it a prosthetically driven surgical template, where the surgeon is given guidance on where we're hoping the screw access hole will emerge, but of course it's bone driven as far as where the placement can be. When we get CBCT scans of the patients, we can then do what's called a fully guided plan, where we import the DICOM of the patient, the intraoral scans that you provide, or we scan your analog impressions, import everything, combine it, and can provide you, if you're not the surgeon placing the implant, you and the surgeon or yourself, with an overall plan based on your direction and the implant system you use or the specialist uses, and give them first right of refusal change for that plan. We're just software navigators. We're not clinicians. We know where to put it, but in the end, whoever uses the surgical guide is the one that needs to sign off on that plan. So why does this matter? Well, let's look at predictability. Right. If you look at our own experiences over the years, when I first started casting frameworks, and I've cast many in my previous time here with Rotsaert, the denture teeth were bonded. So in essence, it was a denture that was bonded to a gold framework at that time. And we had the challenges, the learnings, I would say, where teeth were popping off. We were doing the occlusion incorrectly, where we were locking patients in. We weren't giving them enough freeway space, or what you see in some of these images, the crossover, the laterals and centrals, or the canine guidance, and they start popping off denture teeth. And nobody wants to see this on Monday. We don't want to see it on Monday. We don't like to see any case back. That's not how anybody wants to operate, certainly not from a long-term perspective. We don't make anything that's temporary. We try to make everything last. So what you're seeing here, and they're not all disasters that we've created, that's been shared with me from others. There's material choices that are made, and not every material is the right material for the certain patient. Zirconia is a very strong material, but in some patients it can be very brittle, depending on their function. On the contrary, denture teeth can have their own challenges, in certain patients as well. So, but through this, there's been evolution in the prosthetic restorations, or the prostheses designs, so that we have a stronger backbone. And I'll show you that when we get more into the definitive prosthetics. But part of the challenges we run into with a full arch, or even, let me talk about a single unit or even up to 3 implants, we connect in that precise connection, or the medical device component that has been manufactured. In our case, we provide ELOS and sell and support those components, but they're machined by a medical device company, one of the best, and they in fact manufacture components that are private labeled for many of the other companies. So what that gives us is that connection that's required for a stable screw joint connection over the long term. That is bonded in to the bridge itself. So the weak link in there is the bonding itself, or in this case, if you start seeing divergent or convergent implants or multiple implant connections, in some cases you may have 3 different implant connections in one patient, right? Not just diameters, but I've seen Zimmer, Straumann, and Nobel in the same patient. So there is ways to standardize those, and I'll share that in a little bit. But the complexity comes in seating these bases. So once you start adding or increasing the number of implants to 4 implants, potentially 5, I've done a 10 implant case. And in those cases, by the time you add these bases, there's a little variable or a little play in each of them, and that can exponentially become more accurate as you go around the arch. So when we start looking at doing intraoral scanning for full arch, that is a learning curve for a number of people that have bought scanners, whether you've had an iTero in the past, you've had a CEREC in the past. Both those scanners were developed for teeth, right? They were really intended for scanning teeth. Pardon me. So when we start looking at, scanning all this data in, there is a workflow. And I'll come back to that a little bit further on. But when you're scanning with an intraoral scanner, regardless of the one that you have in your practice, there's a protocol. There's a scan step or scan workflow that every company has. And it's really important that you follow those. I think Mark and I both experienced this where you go chairside and somebody's trying to make a perfect scan of a molar, right? When ideally you just scan the teeth, pause, meaning stop the scanner, let the software catch up, and then you can go to town and continue completing the scans. We see scans sometimes that are not usable, right? So bearing that in mind, when we start looking at using intraoral scanners on a larger scale, there's complexities with implant connections. So I'm going to talk to you for a few minutes just about what we term as transmucosal abutments. So by that, I mean, if you look at just a Straumann connection, for instance, in this particular slide, Straumann's new connection actually has two different planes on any one side of any implant, right? They've got one cone that's consistent through all the implant diameters, but that platform then increases in width, similar to the original tissue level implant. So if you imagine trying to do multiple implants at bone level, trying to get all these planes to fit passively and have a path of insertion, just like imagine doing a full arch bridge on multiple teeth, the draw can become more complex. So transmucosal abutments really help with correcting angulation. So in most cases with implants, they're not perfectly parallel in every patient. They're really more perpendicular to the ridge of the bone. And by putting on an extension or a multi-unit abutment, which is the generally used term, that abutment then can be redirected, or the angulation can be corrected so that every one of those implants has a flat table for you to scan to or to seat to, and it makes it easier for the prostheses to fit passively. So it can save appointments, right? It can also save you the challenges with assessing fit. One thing is the fit with your fingers, but the other is trying to do x-rays, a two-dimensional x-ray of a three-dimensional object, right? There's a lot hidden behind the components that you don't see when it comes to the fit of these bridges. So the transmucosal abutment, sorry, I have to turn that off, is an extension of the implant to bring it up to a manageable level. So the surgeon can place these if you're the restoring doctor. We order them here in the lab if we get an implant level scan or impression in an analog sense. We will order in the appropriate one to correct that angulation, and then it standardizes the top of it. So if you're currently seeing any of these cases or these implants come into your practice, Noble Biocare has had transmucosal abutments since Brånemark's system was introduced back in the 60s, early 70s, with the multi-center study, because they wanted an abutment to seal off the top of the implant to protect the bone, but then move the misfit, because we were casting things out of gold back then. If there's any potential misfit, it would bring it up into the mucosa, it would bring it up into the tissue, and you could also visually see whether the bridge fit or did not. There's a number of what are termed as compatible, different types of abutments. Nobel has their conical shape for the multi-unit, Neodent mini conical, Dentsply has what they call multi-base, a number of other ones like HIOS and Keystone, etc. They have compatible multi-unit abutments. There's one company, DES, that manufactures some of these components, and they're private labeled by these other companies. So there's a universal approach that's happening in the market where most companies are going towards a compatible abutment. Straumann being the exception, where they have what's called a screw retained abutment. When you see these, they use different screws, similar thread, but the screws are a little bit longer and the cone technically is a millimeter shorter. There's compatibility in the seat, and but we can support you, of course, if you have any questions on that. But it's something to keep in mind, right? Because the tooling then becomes proprietary for a lot of these companies. So why are we looking at a different way, to scan? Well, when we see single tooth crowns, when we see 2 implants for a short span bridge or 3, right? Usually with those, we can get an accurate scan from your intraoral scanner. We then can match it within the library, create a model, right, where we're printing that. And then from there, the team here, Richard and Eric, they then can design the case the way they want it, return to you a provisional in some cases or a prototype for a try-in with that patient, and at the same time verify that the fit is ideally passive. Right? When you start going around the arch and you have more implants, the small errors that happen with one implant, of course, get multiplied as you go around the arch. There is, as I mentioned earlier, iTero and Cerac were really developed for teeth, right, where you had small edentulous spaces, and you would scan the occlusals because the scanners really like, they use something called tessellation. So they use a lot of triangles. The software takes that surface scan and all the little dots that it receives or calculates in the software calculation, and it turns them into a curved surface. And it's all little triangles. There's no spheres in this world. It's all triangles. Just the smaller the triangles, the smoother the surface. So what that transfers to us then is, the more that you scan is actually not better. It's actually better. The minimal amount that you scan is actually better for everybody because there's less layers of data that the software has to adjust or calculate, or to be honest, round off. So when we look at challenges here, Elos MedTech, they did a great thing. They adapted the scan bodies. They went away from a material that's called PEEK. It's a medical device material. It's akin to plastic, has a hardness of aluminum. It's been used for many years on the implant world for temporary cylinders and so on. But they were getting feedback from the market that there were slight dimensional changes, and obviously through their own testing, they started realizing that there was some challenges with some scanners. So they introduced what was called the Scan Body 22. It's actually a titanium alloy scan body, but it's got a surface technology on it. The way it's treated, the titanium oxide on the surface, is ideal for scanning. It's actually the ideal texture. And if you've scanned with an intraoral scanner, you'll understand what I mean. Sometimes these different scan bodies, if they're white in color or they're contrasting colors, the scanner doesn't know to keep them or get rid of them. Right. We also have alignment with what we work in the software world is the implant library, as it's called. That DME file, 3Shape has them, exocad has it, which we use, and we download libraries from the different companies. And that library is a certain general size. It's based on X number of scan bodies. When we line them up, right, and I'll show you a video of that, there's different ways you can line them up. So again, if we're doing short span bridges, it's fine, but larger span cases, it's a challenge. We also have tie base tolerances. So like that slide I showed you earlier with all the metal bases, how they're manufactured from the company, and we use the hybrid bases from Elos. The manufacturing tolerances have to be coordinated in concert with the implant companies, right? If their tolerances are out more so than these bases, and Elos provides the basis for Noble Biocare, those tolerances again have to be in concert with one another so that we have a good long-term fit and stability. And most companies are moving over to titanium as a material because there has been dimensional changes, or worse, that titanium connection that's in the scan body moves a little bit. There's a rotation there, and you're seeing all kinds of different adaptations, which I'll show you, that companies are doing to try to overcome this. So when we're working in exocad, we actually use a library that we download. So we actually take this, right? And if you can help us, have your team put in the product code or article number that's on the packaging of the scan body that you have. That helps us. It saves us time running around trying to identify what was used. We have pretty experienced people that know what they're looking at, but sometimes we have some outliers that we don't see that often. But you'll notice here, even by just adjusting the amount of room or area that we want to align with, we can actually get a difference in the fit, more accurate or a little less accurate. These are the kind of R&D projects that we have here all the time, where we're trying to see how accurate our models are or the fit is. So you as a clinician, if you ever have a case where, the contacts are open or something's gone awry, we do our own quality controlling of the printed models to see how they're printing, but also look at how the scanning was done. We may even have an analog impression done as well, just to identify where the errors are. But keep that in mind, because this is the workflow. This is currently what the standard is. So it is what we have to work with. So let's look at Full-Arch then. So there's something called Grammetry. It's a play on Photogrammetry, but it's really a system where, and OptiSplint is the brand name that you will hear about if you haven't already. It is scan bodies, a little bit different than the current designs. And then there's a meshwork, so you actually here this in, you scan all this, and then there's a library again that matches to it. Strom and RevX are reverse engineering. They're reverse scanning from the temporary bridge that the patient already has. So if the patient had a smile in a box, for instance, you then screw on scan analogs, scan that in, and then that becomes the master cast that the fit is generated from. Again, it's it's assuming that that provisional bridge fits perfectly. You also have, there's reference scan bodies. Dynamic Abutment does a lot of different bases, and they're a pretty creative group. But again, it's more of a horizontal type scan body to make it easier for the scanner to span the gap, just like you'll see with Nexus. There's been a lot of evolution since Nexus was introduced, and you can see people trying to come up with different ways to come up with the same kind of accuracy. And then one more recently that Mark and I saw, which looks pretty promising, is True Abutment. But this one, you only scan just the fiducial markers. You don't worry about scanning all of the other areas. So again, minimizing the amount of data that you scan, and then you get a library that's provided to you. It's proprietary. They have their library and they send it over. When we look at photogrammetry, or what Shining calls, their photogrammetry, it's really an intraoral scanner, but it identifies markers on the top of the scan bodies. Then again, it goes into a library. So again, we're getting closer, right? You'll see in this case, there's a bit of a challenge because those scan bodies are still quite spread apart, and they haven't quite figured out, the other challenges there, but they will. Photogrammetry is when we're using a camera, and these aren't new. This has been used in industry for many years, and there's a number of different ones. This is an evening in and of itself. But the scan bodies themselves are screwed onto, again, those transmucosal abutments, and then you're using scan flags of a different type and 3D photo scanning that to, again, get those coordinates of the implant connections. The one consistent thing here that you'll see is they're all on a transmucosal abutment. They're all on multi-unit abutments. Again, the main reason is that it allows to have a more level or standardized platform, even amongst different diameters of implants, but also makes it a level playing field for the prosthetics. With these, as I say, most companies are doing them on multi-units. If you can imagine all the implant systems out there and all the connections for each of those systems, to try to do this at implant level would be immense. And some of these companies are introducing them for the most common systems, and more will come, I'm sure. But at the moment, they're still doing everything on multi-units. So why start looking at Nexus? And we have meetings with the various great implant companies on their photogrammetry systems. There's more coming. You have to look at the investment, and I know there's some people that have them that are going around and scanning as a service. In the U.S., they're a bit more popular. The price gets up, upwards of 45 or 48,000 Canadian. I'm not quoting implant companies yet. They haven't started launching them here in Canada, but if you buy it from the U.S., the last offer I saw was 30,000 U.S. Plus, there's a starter kit of around 5,000 to get started with them. So it adds up. So when you look at the number of cases you do, it's got to be worth it. And we do a lot of them, a lot of full arches, but we have an alternative that is one tenth the cost, and it's completely reusable. So Nexus iOS was developed by a gentleman named Michael Tuckman. I'll come into more of his research in a little bit, but it's about doing the arch scanning with a different type of scan body. It's a horizontal scan body. They call it a scan gauge. There's a library that's specific to every kit, and I'll go into that in more detail as well. So rather than having the global average to accommodate every scan body that may end up in every market, and the labs being able to accommodate that, they have specific libraries for every scan gauge kit. So we actually have a scan gauge kit here that you can borrow. We'll come chairside for the scans as well. There's a staging, which I'll show you again in some coming slides, but we utilize this with your intraoral scanner. We do a completely digital workflow. Right, a few things they identified with the scanner accuracies I'll address in a little bit, but it's completely digital. The digital acquisition of the implant positions, you'll give us a series of scans of the current situation, bite, the upper and lower arches, whether it's a denture, screw retained implant denture, like a temporary denture, or teeth, whatever you're doing, that can all be acquired, plus some additional scans that you're going to provide to us to give us the fit of the position and the implant coordinates. So Michael Tuckman, who is actually a dental technologist, decided to go back to school to become a biomedical engineer. So Michael had started working, he's from Melbourne, Australia. And the team down there, him and a few of his cohorts at school, started looking at, from a research standpoint, why can't we use intraoral scanners? We've heard you can't, but and it's being overused a little bit. You definitely can. There's just steps and reasons to do this. But they started looking at comparing scan bodies, and there's a number of research articles on this. With Osteon Dental and the Nexus iOS system. And there's a great case report if you follow the Institute of Digital Dentistry that'll walk you through it as well. I'm going to give you the Coles notes, if you will, tonight, so you're already aware. And as I said, we'll go through it, one-on-one when you have cases that come up. So Michael started looking at the different scan body challenges and where is the problem with the scanner. And if you imagine, as I was describing earlier, the scanners like lots of surfaces. They like lots of angulations, curves, round areas, so that the scanner can easily recognize where it left off. And if you've ever tried scanning at a dentulous ridge with iTero or with CEREC, or any of the others for that matter, you'll see that it has a real challenge understanding where you are on the ridge, and it gets lost. You'll actually see the scanner turn, or it won't match up with the previous scans. This holds true even with scan bodies, because when the scanner comes up, it comes up and over a scan body, but then back down to the tissue. So the algorithm in the various scanners then starts to average out the distances, and it starts to generalize or average out. So that's why you lose the accuracy. We also know that as you go from one side of the patient to the other, the first half of the scan is more accurate than the second half. And mainly it's the crossing over that midline. And that's why the scan paths are what are described or marked in all of the scanner instructions for use. So they started looking at, well, let's look at a horizontal scan body, but also more importantly, let's close off the tissue so the scanner doesn't have to go down to the tissue and back up to the scan body and back down, which if you look at the previous examples, you'll understand now why. Some of them were too far apart, algorithms still coming on. In this case, by going over the scan gauges and the flat surface, that algorithm doesn't come on. It doesn't need to stitch a lot of material together or a lot of data together. And they went one further, and again, they, meaning Osteon Medical, will actually go and use the point cloud data, the raw data that's in that scan, rather than the image you send to us. They actually use the raw data to further identify the positions of the gauges, giving you the coordinates that they need to mill for the bar. So what does it really matter? Well, if you look at what we do today for implants, we're roughly 70 microns in an impression workflow, model workflow, meaning analog or port. Analog is kind of what we use here internally, old school, as I would say. We then, we can get closer, but again, we have to cut frameworks. We have to do verification jigs to identify where the inaccuracies are, and then register that the model is now as accurate as the patient, right? With the scan gauge technology, with an intraoral scanner, they could get down to sub 10 microns of inaccuracy of the XYZ positions of the implants, right? Which is amazing when you look at the variables. So again, these scan gauges are titanium in material. The other ones that you're seeing here are a PEEK or titanium material, but just cylindrical in dimensions. So each of the kits has a serial number. In fact, each of the scan gauges that are in the kit, and there's different tissue heights, which is why there's two rows here, or pardon me, two sections of scan gauges, just for deeper pocket situations. But each of the scan gauges themselves is identifiable as well. Each of them have individual markings. You can see it here when you have these three little marks here. Each of them have different marks, 1, 2, 3, depending on length. And then there's additional markers on the other side, depending on the depth, as well as the positioning. And the reason for this is, if you imagine you had 5 of them that were all exactly the same, your scanner wouldn't know which one it was scanning. Was it scanning number 1, number 4, number 3? And that's why these markers are there. The scanner knows that I've already scanned that, and it won't jump backwards. Right? I'll show you the protocol or the technique as well to ensure you get a perfect scan. But again, once these were manufactured, sorry, I have to turn off the annotation. Once they're manufactured, again, these are done in titanium. They have an ideally treated surface so that it's ideal for scanning even in a saliva-filled or bloody environment. You need to have them cleaned off. They don't want to be wet or shiny, but they can still be scanned even when there's a bit of moisture on the scan bodies. But these then, once they're manufactured, each kit is then scanned with 3 different types of scanners. There's an optical scanner. There's also a Zeiss contact scanner that's used. All those libraries are used to generate what's now the virtual library that they use, again, to mill the bar for that precise fit. So when you look at the surface area that the scanner has to acquire, right, and the markings that we have, there's actually 7 different surfaces. So I'll show you a video of the scanning workflow. But if you tend to miss, or you, for whatever reason, say you miss one of the surfaces, there's still, a number of other surfaces that can help to be aligned. In the protocol, you'll do 2 scans of these gauges, and that further gives them more accuracy. When everything is overlaid, we get better coordinates or better positioning of the connections. So the scanning workflow, and you'll see on the left slide there, the scan bodies are put together down on each of the abutments. You rotate them into an orientation so that they're not touching, right? You can see a little bit of space between. I just recommend pulling floss through, right? It's okay if they're close. They don't need to be open wide, but we want to make sure that they're close enough so that the scanner is just scanning metal, right? You'll give us other data in the other scans, right? We'll get the tissue contours. We'll get the position of the current situation with the teeth or denture. We just need these, again, for the milling coordinates for the cylinders that end up in the final bar. The rest of it can come from additional scans, okay? There can be some challenges with severely angled implants that might be able to be addressed with an angled abutment. I've seen this once I've been able to scan more than 400 cases. And with that, these scan bodies, if they're really off the ridge or there's some other challenges, you can overcome them. There's different recommendations, and we're here to help. We will actually give you a drawing of where we recommend the scan bodies go. We'll come chairside to make sure that everything in the scanner works comfortably. We also have step-by-step workflow documents for every one of the scanners on the market as well. Not sure if Jen, if you have a poll question on that one. Right. So there's going to be two scans that are created here. The first one is from the left side of the patient. So depending on the scanner you're using, you'll choose a new case for that particular patient. Upper jaw, you'll do one scan from one side to the other. You don't pick an implant workflow. You just do them like study models. You do a scan and you do it slowly. There's no rush. It's less time than impression to get this amount of data. You take your time, you roll the scanner back and forth. If you're using iTero, the video capture works really nicely. You just need to roll it a little bit, not severely. We don't want the cheeks, we don't want the tongue in this scan. We just want to roll it so the scanner is able to see all the surfaces. And you'll get, there's a small technique with this, but most that I've been able to work with, they're doing it after the first attempt. And again, we're just capturing the data of the metal components that you see there, and we'll do two scans. Again, the upper jaw, say we do from left to right. We'll go to the lower jaw. We'll go from right to left. There's no bite needed at this point. We'll get that in other scans. And the data is then exported, processed, if you will, by the scanner. So with the full workflow, so depending on how the patient presents, let's say you have a patient with a denture, they've had some implants placed, right? And they want to do something that's more fixed. Could be a bar, could be fixed prosthetics. You give us the foundation scans, so you do the upper jaw, lower jaw, and the bite. If they're two dentures, you actually can do a 360 scan of each denture outside of the mouth, meaning you're going to give us the tissue as well. You're going to give us both. And then we can take the tissue from that, right, from that scan as well. Then you put both dentures in the mouth, and then you take your bite scan. When you put the scan gauges in, again, all we want to do is minimize, so there's no wrong here. You choose a scan body that overlaps 4 millimeters over on the other ones. We minimize the gap between them. Longer is not better, right? Accurate, minimal data is more accurate than the length that makes a difference. Again, you can see just rolling it back and forth just to get the data. There's additional scans that'll give us the tissue. And again, bear in mind, we have full walkthrough documents for you on this. And then if the patient has a screw retained bridge, so I use Smile in a Box as an example where a patient's had an immediate done or an all-on-4, there's scan analogs that are put on, and they're just there to help us line up, but also to help your scanner keep track of where it's scanning on the intaglio surface. If it's all pink, it has a hard time with pink shiny surfaces. So the scan analogs just lengthen the position of the implants, and that file then everything we acquire here, that helps us build the project in exocad, and we're able to put everything together. So imagine, okay, we've done this. Did I do a good job? Do we have a scanner, a scan that's acquired? Do we know if it's accurate? Well, currently today, we get phone calls, and Richard, I think, sees this on a regular basis, and Eric, but we get a phone call. I've got a patient in the chair. I just sent you a scan. Can you tell me if it's a good scan or not? All right. So how about, what if we had that? So for Nexus, what they introduced was what was called Nexus Connect. It's a web-based portal. So there's a way to do this. We just open it up on a laptop. You take the scans that you did. Remember, there was 2 scans that we did of the same gauges. We don't want to move them between scans, but we have the 2 scans. This software is great. It'll actually tell you that you mistakenly imported the same scan if you didn't choose the 2 of them. You just identify the top of each of the scan gauges rather than, just so it doesn't compare the tissue in this case. You're just telling it what you wanted to identify. Run continue, takes less than 10 seconds, and it gives you a success. right? Meaning green is good to go. That means that it's, and they use AI to feed this machine. What that means is this is compared to 9,000 other scans that are in the database. I think it's over 11,000 now, but at the time when I was working with them, there was 9,000 different scans that were used as the baseline. So you're within that excellent group. So what happens if it doesn't work, right? So we have, this is good. Success is good. What you see here, this gauge on this side, this actually changes a little bit. It's like a speedometer, right? If it's all green, then everything's great. You may see a little less green. It usually means that you may have gone a little fast, right? You may have rushed a little bit. But what happens if we have an alignment failure? So this pops up. Well, there's a heat map as well. And what the heat map shows us is it'll actually show us where there's missing data. All I would do with this, if there's an alignment failure like this, usually we don't get this far because we would suggest that you turn this around so it's overlapping this one slightly, stagger these ones as well, maybe put a longer one in so that we have them already overlapped. But the main reason for this one is whoever was doing the scanning might have just gone too fast. There's not enough data here for the program to say you're good to go. It doesn't mean it's a complete failure. Say you've let the patient go home and we realize the scan wasn't that great. It's okay. We can still go to the design point of having that try-in ready to go, the prototype of the new teeth design that can screw onto those multi-unit abutments, and we have you just rescan when that patient's there. So you don't need to call them back. We will use the next appointment, and it's going to be close. This is still better than a model, right? It's just not as precise as those 9,000 other scans in this example. So why do we do all this? Well, then when you look at what I talked about earlier, when I was referring to using titanium bases, or what we term as hybrid bases for the ELOS family, when you put in multiple, meaning more than 3 or 4 around an arch, right? Quadrants we do every day. Short span bridges we do every day. But when you're dealing with full arches and trying to achieve a passive fit, putting in individual bases into a bridge, which, yes, we cement on a model, but there's always variables. There's always the chance that even in a conical position, those can be out that little bit. And in fact, in Chicago, there was a lot of discussion about intraoral cementation. And I'm sure none of you want to do that, and that's not new. It was done many years ago with the original Bradmark implants, but it became obviously too arduous to keep a dry field and to be able to bond each one. It was a lot of work. So that said, and the evolution from what I showed you from some of those catastrophes in the beginning, having a titanium substructure achieves two very important, to me, key points. One is milling titanium and milling a cylinder for the connection of the implant is easier to coordinate X, Y, and Z in a titanium mill the size of this room and be able to interconnect between all of the implants, that connection, in a much more accurate way. It's a more stable base or material to drill into, right? We're milling zirconia here and then we bond in the base, right? And by design, there's a cement gap in there. Right? This way, we're able to, again, achieve a more passive fit more consistently. But at the same time, the other benefit is that we have a backbone for the restorative material, or for the overlay, if you will. We can do those in zirconia and we can thin them down. But more importantly, we can also use a more aesthetic zirconia. You can use a Y4, a 4-layer, some cases a 5-layer, but that's a little rare. We'll do those for singles. But you could do a Y4, where you've got 4 layers of zirconia, where you have a little bit more of an aesthetic result rather than what we have to use with tie bases in a full arch, like a 3-layer or even 2 or mono, where we need, we want the strength, but we're not getting the aesthetics that we want. It's paint on aesthetics, if you will. So again, the force distribution is better on this. The cement surface area is so much more than what we would get with an individual tie base, and we can do the overlays in zirconia or in PMMA. Right? So imagine if you have a patient that is doing 2 arches You want zirconia for the aesthetics on the upper jaw, but for longevity, possibly do PMMA on the lower jaw. And this is fairly routine here. I get nervous when we do 2 arches in zirconia. But again, we can go with a more aesthetic zirconia and still achieve down to 8 millimeters of restorative space, or call it tissue to occlusal opposing space, to be able to have enough strength within this restoration. Again, the bar itself being precision milled, seats down, of course, on the implants, so it'll all be retrievable in this example, right? The overlay is then bonded on. It's a material, it's panavia essentially, but a mixture of it, and it's used to bond it on, right? We do fusion bars every day as well from Panthera as well, where we bond on the zirconia or the PMMA for those particular patients. So when we look at the options for the different bridges, the most common one we see is what's called the Nexus Hybrid, like a fusion bar, where there's an anodized gold bar for the fit, obviously, to the implants, but then we have some pink present on the restoration. So where we're missing a little bit more pink, if you know the MISH classifications, and fixed prostheses, a 2 or a 3, where we've got more pink or bone and a combination of material missing, we need to replace it. The Nexus bridge is what would be an FP1 in that world, meaning there's no pink. There may be a little bit of pink interproximally for aesthetics, but primarily the bar is minimized. So it's a narrow bar that goes down the middle with a margin for a seat, but the bridge itself is all tooth shade, and meaning all overlay from what the patient would see as well. I mean, the gold anodizing is really nice, but it's really more of a delivery to the patient, right? The anodizing does change over time depending on the foods the patients eat. That anodizing can last for years or months in some patients. We also have the Nexus 360. So what this is akin to what we call a wraparound. A titanium bar, again, precision milled for the seating. The overlay is PMMA, goes over top, but the intaglio surface is actually acrylic. So it's actually acrylic in its own sort of pocket wrapping around the bar so that you can reline it or add to it if you need to in the future. So again, the most common one we see is the Nexus Hybrid. We've also done a patient removable. This one is a bar and sleeve. You may recall our fixed removables, where the bar is screwed into position by you. The patient then can disconnect, remove the denture for cleaning, or if there's a lot of lip support that's required, due to a lot of missing bone levels or obturators, you can then reposition it, snap it back into place. The overlay being PMMA. You wouldn't want to do that in zirconia. Right? So again, framework, that backbone, the substructures, that titanium framework, I've talked enough about that, I think. The overlay, again, the overlays can be done in zirconia or PMMA, and it allows us to individualize for the patient, right, for the different aesthetics. Full arch, from a shade perspective, tends to be a little easier, unless we're matching a challenging opposing arch. But, the shades tend to become a bit more generalized when it comes to the full arches. Right. So again, there's some examples here of both the Fusion bar and the Nexus Hybrid to give you an idea of what they look like. So again, there's a titanium frame overlay of either zirconia or PMMA in there as well. So, why else do we partner with this? When you look at overlays or the PMMA, the confidence is continuing to come in these. The zirconia overlay, so the bars themselves are lifetime warranty from the Osteon company. The overlays are now up to 5-year warranty on the overlay, or 2 for PMMA. And the main reason is that the material itself does show some wear. There is some need to revisit, but fortunately with PMMA, we have the file, right? We have the patient's bite. So all we would ask is that you give us a new scan of the bites, give us the lower bridge. We still have the try-in, if you recall. We still have that prototype that can be screwed in temporarily, but then we can remill an overlay, swap it out, put in a new one, and they carry on in good function. Right. I haven't seen or heard of these in 5 years needing replaced yet, with the exception of one patient, and it was obviously covered under the warranty. But the patient had a zirconia maxillary prosthesis and a PMMA mandibular prosthesis, and they literally compressed it down to the degree where it spread out.